Hello Dave, let's solve this question which came in weekly contest 470. The question is longest subsequence with non-zero bitwise XOR. You are given an integer nums. Return the length of longest subsequence in nums whose bitwise XOR is non-zero. If no such subsequence exists, return 0. A subsequence is a non-empty array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. Okay. So if you see this example, what we have to return is basically the length of subarray, length of subsequence, where which has XOR. Let's say we have subsequences A, B, E, F. Then A XOR B XOR E XOR F should be not equal to 0, and that we have to return this length, max length. And if we have this okay, yes, this is what the question is. Now let's say we have an array nums, not number, I'll not take the number. Let's say A, B, C, D, E, F and G. We have this array. We have to find the subsequence which has non-zero XOR. So if you first see the XOR properties, what are the XOR properties? Is basically, if you take, let's take x XOR 0 will be x XOR x will be 0. So if both are same, if both the elements are same, the XOR value will be 0. If not, we have, let's say, this 0. If you do XOR with x XOR with 0, we will get the x. We can have some value x XOR y can be z. Okay, so these are the properties of XOR. So first you should know this, then you can come to solve the question. So see, what will be the brute force approach? My brute force approach will be what? It will be using recursion. How? Okay, how you will solve this using recursion? Because there are choices. What choices you have? You can choose this element in the subsequence or not. So to find the subsequence, okay, to find the subsequence, what you do is you can use the recursion and find all the subsequence, and then find all the XOR of subsequence. Then you will check if the XOR is 0, then no. If XOR is not 0, then you will maximize that value. Try to maximize that value. But here, this is the brute force approach, and you will get TLE here. Okay, because here you will be saying all the possible subsequence. But the trick here is, see, if you have the same element, okay, then you get XOR at 0. So let's say, for example, I have the numbers 1, 2 and 1. If I do the XOR of these three, what I'll get? The value I'll get 2. Why? Because these are equal. Now if I remove any one of this, what I'll get? I'll get 1 XOR 2, which will be some kind of value, but not 0. Okay, so my answer will be this. So here, if I do the XOR, if I find the XOR of this nums, okay, A XOR B XOR C XOR D XOR E XOR F and XOR G, if I get 0, that means there is a pair, okay, there is some X and Y which are same. This can be, let's say, my A XOR B and C, this can be same. My A XOR B XOR C can be same with D. Okay, so if I remove this D, I'll get non-zero XOR. Okay, that's the trick here. So my answer will be either my N or N minus 1 if my all the elements are, if my array is not this array which has all the zeros, because in this case our XOR will be 0 in all case, so my answer will be 0. So my answer can be only what? 0, 0, n, and n minus 1. Why n minus 1? Because if we remove that element which is making our XOR of all the element as 0, then we'll get n minus 1. And we don't really have to remove this element, because in the question what is asked, we are asked with length. So we can directly return n minus 1. So first we will what? First we will find the XOR. We will find the XOR of all the elements, and then what we will do is, if it is let's say if my XOR is 0, that means there is some element. So what we will do, we will return n minus 1. That means if we remove one element, we can get non-XOR value, non-zero value. One more thing, see, it's not necessary we have this with D only. We can have XOR of A and B. Okay, A and B with what? With E and F as well. But if I remove this F, I'll get E, and E XOR A XOR B XOR E will be not non-zero. So we just have to remove one element, then we'll get the non-zero XOR. Okay, it's not necessary that with only one this D will be same as this XOR. Okay, so yes, first we will return minus 1, else we will return n. And one more thing, our answer can be 0 as well when our array has all the values as 0. Okay, so in that case what we will do, while finding the XOR, we will find the count of 0. If it is equal to length of nums, then we will return at 0. So now let's start coding here. What we will do, first we have to find the XOR. I'll take this XOR initially 0. So for int I is equal to 0, I less than nums dot length, I plus plus. Here what we will do, XOR with nums of I. This is just a variable name, don't get confused. And what we have to do, we have to find the count as well. Int count is equal to initially 0, and if my nums of I is equal to 0, then we will increment our what? Count 0. And what we will check, if my XOR is not equal to 0, that means we have our answer as n. Else, in that also we have condition, if my count 0 is equal to nums dot length, then what we will return, we will return 0, because we cannot make the subsequence which has non-zero XOR. Else, here we will return, we don't need to write else, we will return the n minus 1 here. Okay, now let me run this. Compilation error, cannot find this count. Okay, here I used count only. Let's run this again. N minus 1. Okay, let's take int n is equal to nums dot length. I forgot to, and I can use here n, and I can use here also n. Yes, now let's run. Yes, you can see it is accepted. Let's submit this solution. Yeah, here you can see it is accepted. So in this way we can solve this question. This is a trick to solve this question. You don't really need to find the subsequence, just have to understand the pattern. Yeah, thank you so much for watching this video. If you feel this video is helpful to you, please like this video, subscribe my channel, stay updated.